demoed anything from my dev project, but I have been making progress on it. So I have added, I've basically been integrating things. So I finished the implementation of the voxel engine that I wanted to use for the underlying planet tech. There is like one remaining bug that I have yet to fix in that, but for the most part, it's solid. And I've been just integrating the various like sub projects that I had over into the master project and integrating them together into a wrapping planet actor. And I finished that. So I wanted to demo it. It's pretty cool. There's still a lot of work to be done, but this opens up a lot of possibilities going forward. Um, if you've seen my videos before, you may have seen the quad tree based planet implementation or the voxel stuff that I was working on. So this basically supersedes that um, and is better than that in every way. A, it's less complex conceptually. B, it's faster because of a whole bunch of optimization that I did. Um, and I'll kind of go over that. Um, C, you can edit the planet surface. You can terraform, which you can't do with a quad tree based. So you could do things like destruction effects or like literally just tunneling into the planet and things like that. So we'll just go ahead and load this guy up. And there's a bunch of like quality of life stuff that I've done here too that are better. And I'll kind of get into that as well. So this is our planet actor. Um, I haven't done too much on like surface and ocean materials yet. They're very uh, minimum that I like minimum level of development that I could do to actually use them as an example. But I would still need like a whole probably week or two on each to get them polished up. Just fully focused on the materials. But I do have some placeholders in place, which should be good enough for demo purposes and for demoing like what this actually is. So, what do we have here? We have a planet actor, and that has a adaptive voxel actor, which is actually doing the planet surface. It has an ocean sphere actor, which is rendering the ocean surface. It has an atmosphere actor, which is controlling the atmospheric ray marching effects, and has a planet gravity zone, which is what I just recently migrated in here. Um, so these are the kind of five pieces of our planet as it stands currently. I'm just going to wireframe it so that we can see, and we'll just grab this. This way we can kind of see. Oh yeah, so we're at a baseline 1,000 kilometer radius by default. So this planet here is 1,000 kilometers in radius. We can go up to about 10,000 kilometers before we start seeing precision issues, and that's just because I have restricted the chunk depth to max out at 5 because it's slower. Like the deeper the chunk depth is, the slower it runs. And at 5, you can get out to about 10,000 kilometers or so, maybe a little bit less than that, but it's like somewhere in the 8 to 10,000 kilometer range. So you can kind of see the optimizations that have been done here. This is all real time, and it's also, these are not like quads, like quad tree based. This is all um, voxel based, so everything here is 3D. It has depth. And then the other cool thing that this can do that my other one never could, which is going to come in really handy when we start integrating this with like the parallax systems in the like very large scale project, is we can. Oh wait, if I select the root level planet actor, I can move the whole thing. And it moves fine. There's no lag or anything like that. And the other cool thing about being able to move it is that the LOD still works while we're moving it. So it's not just based on the player's position. Um, we have the ability to move this and have the LOD continue to update while we move it. which is really good because this is going to need to have its own parallax movement to move it around after being spawned in that would eventually be zeroed out. So let's just take a look component by component here. So we will start with the adaptive voxel actor. We'll turn everything off and go to unlit or even wireframe. So this is fully 3D. It's based on an octree. We've done a ton of optimizations. Um, we have near surface optimization checks where we won't split any nodes that are not at least within one radius of their corner distance from their center from the surface. And that means that we have a lot of nodes that don't need to split that otherwise would. We have chunking based multi-threading, so we break this down into chunks, and that is how we can maintain precision at large scales because each chunk builds its mesh in its own local coordinate space, and then we move the chunk to its position on the surface of the sphere. And that allows us to basically build enough precision to where we can build these very large planets and move around on them without a bunch of precision issues without having to like do something weird like have double precision mesh or anything like that. Like all the mesh data is all in 32-bit, but the chunks themselves are moved to the surface of the sphere. So that allows us to do that. You can see kind of the speed at which it's doing the lotting. We've done a bunch of optimization here on that front to make this like actually performant. I just have a default kind of placeholder noise texture in here. Oh, and the last bug was popping up there. So occasionally off here in the distance we'll get like poorly connected tries. And I think this is a synchronization issue, but I haven't really dove super deep on fixing it yet because everything seems to work pretty well close to the camera. Um, so yeah, this is it, and we can go really fast, and it runs very quickly. Likewise, merging back together, it does that pretty quickly. So that's just like the surface level overview of this guy. We control its size with the scale parameter. We have things like noise amplitude ratio, sea level that are getting set at this top level and then propagated down to the subcomponents. We have our materials for the ocean and surface here. We have an enable ocean checkbox that can allow us to like completely skip the ocean object, which seems like that's a pretty good time to move to the ocean object. So the ocean is a quadtree. And you'll notice that some of this is cold. That is because we are encoding the depth of the water table at each vertex. And anytime that depth is below the surface of the land, we will not generate those triangles. So this is quadtree based because the ocean is just a surface. And other than that, it works similar to our voxel engine. It has the same kind of lotting, adjusted for the fact that it's a quadtree and not an octree. But and then we have kind of a placeholder texture on this as well, a placeholder material. Let's see if we can get some. Okay, I'm on the dark side of the planet, or no, I'm not. Let's go maybe over to the light side of the planet. So I did a real quick and dirty fractal wave function for the surface of this. It's not using like FFT or anything like that. What it is doing is basically generating a fractal set of Gerstner waves and compositing them. Haven't done any work on like translucency or ray marching below the surface or anything like that, which is why everything is just completely solid. This is just kind of a proof of concept to show that we can, yes, we can do waves on a sphere that work well. And it has a couple other things like we're doing some normal wizardry to make the normals kind of blend together as we get further away so we don't get a bunch of like artifacting from far away. And then the other thing is at the shoreline, And this is why part of the reason we need the water table depth. And ignore this. This is another thing that I haven't fixed yet. But it's not as bad without the editor open. At the shoreline, we reduce the amplitude of the waves. Um, and that is just so that we don't get a bunch of like weird behavior of the waves interacting with the shore when we're on like at the boundary, like at the beach, basically. Like if we go over here, we can take a look at what that looks like. And we go down, we can see that we have enough to give it some very like small amounts of like waves coming in and out, but we don't have the like large uh, deep water waves that we get out further from the shore. Um, so yeah, that's the ocean as it stands. It's literally just the quad tree version of the octree planet that takes a material that is doing this kind of Gerstner wave function. Um, and like any of these could I could go into like a very detailed breakdown of how it's all working, but I'm just trying to give the overview of the whole project. As far as the land, I've set a very, very rudimentary landscape texture on our landscape material on this. All we're really doing is we have our like beach layer. It transitions into like a grassy layer with some variance, and then we have our normal mapping between the grass texture and the ground texture or the grass texture and like the underlying rock texture for things like cliff faces, sides of mountains, things like that. So next up, we have the atmosphere shader, which I've done a ton of work on over the past little amount of time. So this is basically a wrapping actor for our atmosphere shader. It controls a bunch of material parameters. Oh, and also any of these you can edit everything except for their transforms on the actors themselves. Um, the planet actor basically marshals the transforms for all these different things and sets all the things that are derivative from like your base planet scale. But all the other parameters are set in the subcomponents. So like if I wanted to change the color of the atmosphere, for example, I could come down here to scattering and just swap the type of scattering we have, and we get different realistic atmospheres based on the color. It does like a really, there's a ton of optimized ray marching in here. The clouds are fully opaque and volumetric. So we can fly into a cloud, and now we're in the cloud. We fly below the cloud, now we're below the cloud. We get sunset colors. We get atmospheric shading from the clouds themselves, or atmospheric shadowing from the clouds themselves, where the clouds project their shadows through the atmosphere and onto other clouds and all that stuff. Clouds are also participating in scattering, so we get some nice coloring on the clouds on like the sunset side of the planet. It also gives us the ability to have kind of the cool um, halo around the planet when like the sun's on the edge here. And kind of this is a like a idiosyncrasy with the not bloom, fuck, exposure. I need to tune the exposure right because like this brightens up into like the dark side ambience when you're near the surface on the dark side, so that your night sky isn't completely black. You can still see clouds. You can still see kind of the like horizon glow that you get at night. Um, and then the other cool thing about the atmosphere is that the atmosphere is the only one of these subcomponents that has an unbound transform on the rotation. So if you rotate the atmosphere, what that's going to do, it changes both the atmosphere light direction for the material and the light direction of the directional light that the atmosphere owns. So for instance, if I rotate this, um, the light direction changes for both the material and the directional light. That keeps our starlight and our terrain lighting in sync with each other. So like our the way our scene is lit down on the ground is always going to look the same. Uh, is always going to look the way it should for whatever angle our atmosphere is at. So we have that in bound. You can also do this number or any combination. Um, and yeah, so that's how that works. Finally, the thing that I just finished integrating is the planet gravity zone. So I integrated my custom gravity project into this project. And what that means is that if I come down here to, say, the bottom side of the planet, where formerly, without the gravity plugin, if I were to, say, try to spawn in down here, maybe on this island, or to try to spawn my character in on this island, we would just fall straight down on the z-axis because we were being affected by normal like scene gravity. But now, once we spawn in, we now have spherical gravity, so we fall towards the surface of the planet no matter where we're at. As long as we're within the bounds of the gravity's effective zone, then your character is going to fall towards the planet. um, and we can kind of see the lotting in practice. You kind of like the speed that our lotting is happening at for generating the mesh is actually overkill for walking on the surface of the planet, but we wanted to be able to support flying over the surface of the planet at high speeds. So I really wanted to optimize the heck of it out of it. We're currently looking at somewhere between 30 and 100 milliseconds for each LOD pass, which would include subdividing any areas that need to be subdivided and meshing them. So we have less than a tenth of a second turnaround time to basically perform these LOD changes as the player's perspective changes. And then the other cool thing is, like I was saying, the nice thing about this being a um, voxel based planet rather than a quadtree based is that this is not just a surface. We can do terraforming. We can terraform stuff. We can carve the terrain. We can also add to the terrain. And I haven't really done any major work on like making these controls make a ton of sense or anything like that. But just kind of proof of concept stuff. Like here's how you can do a positive addition to your voxel, to your like density data for making the planet surface. Here's how you can carve a hole, and this is running a little bit slower than normal, probably because of OBS. But yeah, so we can chop this up. It'll stay persistent. So like if I were to pop out of here and zoom out, it all gets merged away. But then when we go back down here, close, if I can find where our player is again. This is one of the problems with it being so large. Is that okay? It fell through the planet. Is that if I make a change, it's hard to test that like it stayed persistent. So yeah, this gives us the ability to have persistent edits. If we have the if we wanted to, at some point I would do this, but not probably not in the near future. If I went and I serialized the contents of the edit store, then we could make these changes persistent not just across this edit session, but across all like multiple sessions. Like you could save it basically permanently into the planet. Um, yeah, and so this is the state it's currently in. We are probably coming pretty close to the point of pulling in the ultra large scale project to this as well and starting to rig this up with parallax motion at the planet level so that we can start spawning it into our universe simulation at the star system level when you it'd be like a little volcanic depression or something like that. at the star system level when you are flying around the universe. And then we would be spawning this in real time. So another thing we can do is we can just delete it like that, and it will clean up everything after itself, which is important because we would be spawning and despawning these pretty quickly. And then also we've optimized the spawn to be fast, hopefully. Oh, no. Okay. Let's try this again. I haven't shaken all the kinks out of it yet, obviously. Um, but I think there's still some weird behavior going on when you delete it and then try to spawn another one. It doesn't super like it, so that's something that I'll be chasing in the next few days. All right, so we're just gonna let's try this one more time. Delete, delete. That should clean up after itself, and then can we drop? Okay, we drop and it's spawned. So one of the problems with this thing, another problem with this thing being so fucking big, is that it's kind of hard to judge what the appearance of it spawning in would look like immediately, right? But we can just go ahead and try to slam another one. Okay, yeah, it doesn't like that. So yeah, like obviously, I have issues to work out here, but kind of the bones are here for the next part of what I want to do, which is integrating this into the universe sim. And once that's done, you would be able to walk around on a planet, fly out into space, and then walk around on a different planet, which was the goal with no load screens or anything like that, which was my goal from the start for this project was to accomplish that. But it spawns in at least faster than I can get over to the location to recenter it. Also, every part of this can be customized. So, like the right now, we just have a static noise formula we're using, but you can make all kinds of different noise formulas to do different planets. I also figured out how to do custom fast noise 2 nodes, which opens up a lot of flexibility in us, like basically uh, being able to just use that fully as our noise library and not need any like post processing or anything like that. Because if we need post processing, we can just go make a node for that in our fast noise implementation. We can go create that SIMD node and have it do whatever kind of post processing you want. Like one of the ones I'm working on now is like an erosion based on a video I saw of a fast erosion method. So yeah, I want to try that. But yeah, that's pretty much it. I think the planet is maybe not done, but like mostly done for the most part. Oh, and this is the texture we have on here is the normal, or the material is the normal material, um, because I sent this back to default. I think empty surface was the one I put in place for kind of our default texture here. Although some wire got crossed here, which is fine. I'm not setting up the surface material for the planet in the blueprint yet. So, and we like obviously we don't have any under the water effects on the camera yet or anything like that. Haven't done any like at some point I'll do a whole like basically pass on like polish for the ocean. And as a part of that, I want to implement the fast Fourier transform based oceans, but I also want to solve like stuff like this, the seams here, and like the disjoint chunk boundary, or this is actually tree boundary texturing here. Um, but yeah, I mean, for the most part, it's pretty close to done now. Like I said, this is 1,000 kilometers radius, which is big. Way larger than you would already be encountering significant precision issues at that scale. But let's say we wanted to make it Earth-sized. So I'll go ahead and swap this to 5,000 kilometer radius, which is just a hair under Earth. Or actually, you know what? Let's go a hair larger than Earth. That way we can be sure. All right, so here we are. This is larger than Earth now, a few hundred kilometers larger than Earth. We're just going to go ahead and fly up here to the surface, get out from inside the planet. And yeah, let's drop in somewhere. How about right here on the coast? All right, we spawn in. We drop down. We should be able to do this with no precision issues. So the way that works is like it basically determines based on how big you set the planet actor, what your chunk depth is going to be. And your chunk depth is what is giving you the leeway to have precision at large scales. So, like with a 5 chunk depth, we should be okay here. Yeah, our actual precision is a little bit under a meter, which is what we're shooting for. So it dynamically just determines based on size what your in target precision, what your max depth and actual precision are. If I go down here, we shouldn't be vibrating. Yep, no vibration. We have solid motion on the surface with no issues or anything like that. No precision based jitter. We can still edit. And like for example, um, what if we wanted uh, to feel a lot heavier? Like this is currently set to um, our normal kind of Earth-based acceleration. What if we wanted to do double that? Okay. What if we wanted substantially greater gravity? And also, the player character has access to this. So at some point, we could do something like a pass on the player behavior based on gravity. And as gravity gets heavier, we could make the player droop or drag or walk, or past a certain threshold of gravity, we could make it impossible for like you just die and ragdoll into the ground or whatever. But like right now, you're running, you can see that the gravity is affecting the jump and your falling speed. Like if we were to eject and spawn in a little bit further over the planet, we will fall faster because we have higher gravity. Hang on. We got to get to it. Okay, we'll change it here because this will be back to default. Let's multiply this by 10. So we do that, we immediately start falling much faster and accelerating much faster. And I suspect we won't be able to jump at all. Yeah, we like try, but fail. And you would do things like set thresholds like above this gravity you can't jump, above this gravity you can't run, above this gravity you like drag, and you know what I'm saying? Like you could do all kinds of stuff with this. This is just kind of the base system to like set the groundwork for a lot of like playing around with this system. It's pretty cool. We can also create nested gravity zones so that we can create like a ship that you could walk around inside of while within the gravity of the planet and have the gravity of the planet affect the ship, and then the ship have its own frame of reference for the player. I haven't built that. I haven't built a ship for this project yet, though, so I don't have anything I can really show for that yet. But theoretically, it can do that. Obviously, we can carve the terrain, build terrain, which is part of the reason that I wanted to do it with a voxel-based solution. We're using adaptive manifold dual contouring algorithm with a bunch of optimization enhancements for our specific use case. At some point, I will also make a like debris field that can do like asteroid zones and stuff. The cool thing about this approach is that our voxel engine can actually be used for all the mesh generation of all terrain and space objects, instead of the instead of requiring like a spherical object like the quadri based solution. This doesn't require the object to be spherical. It doesn't even require the object to be contiguous. We could do a field of asteroids with the right noise formula, and it would just work out of the box. Like, you obviously wouldn't use the planet actor. We'd make like a debris field actor or something like that. But the voxel engine itself would work out of the box, and you could go mine some asteroids in space or something like that. So I'll go back to lit. And yeah, obviously I haven't done any kind of PCG for foliage or grass or anything like that, which would be a huge realism improvement. I have this bug, this triangle bug that I need to chase down at some point. But aside from that, it's pretty good. I think it's definitely getting there. Also, we have infinite dig depth. Although there is just kind of a natural phenomena that happens based because of the way our SDF is constructed that will make it impractical to dig past a certain depth. But you could do it. It's just impractical. Basically, as you get closer to the center of the planet, the density is increasing, and our brush will become less effective because the brush is just changing density levels. And if you're changing higher density values, then all of a sudden it takes more work. It takes more effort to like clear the same amount of space. Let's see if we can make it back up to the surface from our tunnel. There we go. We tunneled from over there to over here. Uh, but like the planet as it stands here, this is too big to be practical. Like, honestly, like above Earth-sized planet is like so freaking large that there's almost no point in doing it. Which is why I said the default's at 1,000 kilometers, like this. Like we max out the camera and it's like it's like slow, right? Which is part of the reason that we need the parallax stuff integrated in here. But yeah, okay. That's pretty much it. That's a quick demo of this. Maybe at some point I'll do breakdowns on the individual subcomponents. But yeah, later.